There are a couple of unusual things that can happen when you're solving a system of equations, so let's take a look at those. Here's my first system here. It looks like it's kind of set up and ready to go for elimination. I see I have positive 2x in the top equation and negative 2x in the bottom equation. If I add together right now, my x's will be eliminated, so I'm going to go ahead and do that. 2x plus negative 2x, well, that's 0. Y plus negative y, or negative y plus y, also 0, equals 4 plus 5, which is 9. Oh, well, so my equation now says 0 equals 9. I don't know why it wants to put that extra 0 in there. I'll just keep taking it out. But there's a problem with that. The x's and the y's are both all gone. There are no variables left, and I have 0 equals 9. Well, last I checked, 0 does not equal 9. That is a false statement. 0 and 9 are different numbers from each other. They're not equal in any way. However, this was not a true or false question. This was the question, what are the values of x and y that solve that system of equations? What values of x and y will make both those statements true? Well, 0 equals 9 is never true, no matter what x and y were. So if I do this, I'm solving my system of equations and I end up with no x's, no y's, and a false statement, no matter what x and y were. That system of equations doesn't have a solution. There are no values of x and y that will make 0 equal to 9. It's not going to happen. Well, how did this happen? What does this mean? I'm going to look back at my original equations up here, and I'm going to put them both in slope-intercept form, since we said long ago the solution to a system of equations is the intersection point of the two graphs. Let's see what that looks like. So if I put my top equation in slope-intercept form, I'm going to subtract 2x, and then I'm going to multiply through by negative 1. So I have y equals negative 4 plus 2x. My second equation, if I do the same, that's a little faster to do. I have y equals 2x plus 5. If you think back when we talked about equations of lines, the slope of my top line is 2, the coefficient of the x. The slope of my bottom line is also 2. When I have two lines that have the same slope, that tells me my lines are parallel. Well, if I'm looking for the intersection point and my lines are parallel, I'm going to be looking for a really long time because parallel lines don't intersect. My top equation there, I have a y-intercept of negative 4 and a slope of 2, goes something like that, more or less. Second equation, I have a slope of 2 and a y-intercept of positive 5, something like that. So my two lines are parallel. Use your imagination, they're parallel. They're never going to meet, which goes along with finding the intersection point. There isn't one, so this system of equations has no solution. My next system of equations, I would like to solve as well. This one looks like it's set up and ready to go for substitution. I already have y equals 3x plus 7, so I'm going to go ahead and substitute into the second equation. I have 6x minus 2 times, instead of y, I'll put 3x plus 7 equals negative 14. Let's see, we'll distribute. So I have 6x, and then minus 6x minus 14 equals negative 14. I don't know where these like extra numbers come from. It just decides to put them in sometimes. There, that's what we meant to say. Combine like terms. 6x minus 6x, that's 0. If I add 14, I don't even have to do that. 0 minus 14 is negative 14. And on the other side I have negative 14. Well, yeah, negative 14 does equal negative 14. That's a true statement. Again, all the x's and y's are gone, but this statement is true. No matter what x and y were, negative 14 does in fact equal negative 14. Again, this wasn't a true-false question. It's what values of x and y will make that statement or that system of equations true, will make both of those equations true at the same time. I would like to do like we did on the last one. Let's put both of those in slope-intercept form. Well, the top one already is in slope-intercept form. That's nice. Y equals 3x plus 7. The bottom one, I'm going to need to subtract 6x and then multiply everything through by negative 1. So I'll have 2y equals 14 plus 6x, and then solving for y, I'll divide everything by 2. Y equals 7 plus 6x. That's the second equation. Sorry, not 6x, 3x if I divide 6 by 2. There's the second equation in slope-intercept form. There's the first equation. They're the same. These are really two equations for the same line, which means every point on that line is also a point on the other line since they're the same, which means all points on that line are solutions to that system of equations. So all points on the line y equals 3x plus 7 are solutions to this system of equations. There are infinitely many of those. A word of caution, we can say infinitely many solutions, we can say all points on that line. We can't say all real numbers. Because if I pick an ordered pair, say 0, 0, if I put 0 for x and 0 for y, I get 0 equals 7, which is not a solution to that system of equations. So it's all points that are on the line, not just all values of x and y, but all points that are on that line. So infinitely many solutions when we have two equations for the same line.